Hello and welcome back to Elementary Algebra. We're talking about intercepts, horizontal and vertical lines. That is going to be 3.3. So we're still dealing with graphs and hopefully graph paper is ready to go. So far we talked about graphing in general, way to find where the points are, which are like a location, right, on the XY coordinate system. So we said before that something like this. Oh, why you red? There we go. So something like this is called XY coordinate system because it consists of X and Y axis, and you have the origin which has 0, 0 in the middle. We said we have 4 quadrants and they are calculated or counted counterclockwise, and that every point will always have to be x comma y. So anytime when you see numbers given, let's say you are given -3 and 1, you will go -3 on x and then 1 up for positive y, and you will have your point. You can label it A, and you know it's in Q2 because it belongs to that quadrant. So this is what we have done so far, and then we talked about having another point. Let's say have point B. Let's call that one, I don't know, 6 and 3, whatever. So 1, 2, 3, 4, 5, that's a 6. 1, 2, 3. So this would be our point B. Now what I can do is I can connect these 2 points with a straight line. Now we'll be doing a lot, obviously, in this course later on with these lines.
That's cool.
And we can have many points and we can connect each one of them and create those graphs that we discussed last time. So this is all old stuff. Now we are introducing something that is called X and Y intercepts. Now let's actually make that red. And now what are X and Y intercepts? So X and Y intercepts, and we can underline this, are points on X axis or Y axis where the graph, remember that's the line, crosses from one quadrant to the other. So very simple. If you take a look at the graph of a line, this is all crooked. Much better. So we see that you have the x-axis over here, you have the y-axis over here, and then we can just draw whatever line. This point here is called the x-intercept, and this point over here is called the y-intercept. And it should be common sense to have those names because x-intercept is on x-axis and the y-intercept is on the y-axis. Now, looking at this picture, you see that clearly, right, line crosses here, right? between quadrants 1 and 2, and over here line crosses between quadrants 2 and 3. So intercept is always on the axis. It has the name given by the axis on which it is, and it always is the place where when the line goes from one quadrant to the other quadrant. And technically that's the entire wisdom of the name. Now, the interesting thing here is to note that every x-intercept is of the form x, 0. That is a 0 right there. And every y-intercept is of the form 0, y. So these are always the case, because along x-axis y is always 0, and along along y-axis x is always 0. So if you are to draw another case over here, let's go with if you observe this point here, this point is 0 on x and 4 on y. This point here is 0 on x, -2 on y. This point over here is 0 on x, -6 on y. So these are all points. These are all points on y-axis, and if the line is going through those points, they will all be called y-intercepts. And as you can see, each one of them has 0 for x and the number for y. If you look at the horizontal line over here, you will have -3, 0. Over here you will have 2, 0. Over here you would have 3, 4, 5, 6, 7, 0. So these are all points on x-axis, and they are all of the form x, 0. And then these are all points on y-axis, and all of them are of the form 0, and then we get the y, whatever number they are. So the points can be on these axes, and they will always have either 0, number or number, 0, depending on which axis they're on. Now that helps us to figure out intercepts for our what we call straight line, linear line. So let's say that you have the line where you don't know, right, the values. You have to figure it out. So let's say something similar to the last class. So x minus y equals, let's say, 2. Now, if you studied anything, right, from the last class, you know immediately that you can create the table of values, and then you can compute maybe first 2 or 3, and then use the pattern to compute the rest. So let's say you take the pattern of x is equal to, you can pick any numbers, -1, 0, and 1, let's say. So last class, you learned that you are supposed to plug those numbers one by one into x and compute y and write the answers in the chart. So we start with -1 minus y equal to 2. What would be the first step to solve this equation?
Add 1.
Add 1. Okay. So that will leave us with negative y equals to 3. And now what do I do?
Divide -1.
Perfect. And we have, when negative cancels, y equals negative 3. All right. What do I do for the second one? We have 0 minus y equals to 2. Do I have to write the 0? I'm sorry, that was really...
Yes.
Yes.
Negative y equals 2.
Negative y equals 2, and then what's the last step?
Divided by the negative 1.
Perfect. So y equals to negative 2. Awesome. And then what would be the next number without computing if we are observing the pattern? What is the pattern from this number to this number to this number?
-1.
-1, perfect. All right. So now we draw our coordinate system. And we can take a look at the intercepts and all of these cool things that we can figure out. X, Y, and I'm going to use 2 units for one because its graph is large enough and the numbers are sufficiently small. So I can just go like this. Goes all the way out to -4. And then we go down negative numbers. Right. First point, x is -1, which is right here, and the y is -3, which is right there. So they will intercept right here to give us our first point, -1 on x, and you can label it A if you want to, -3 on y. Now 0, 2, 0, -2. 0, -2 is on the axis right here, and we can label that one as point B. And finally, +1 on x and -1 on y. So they intersect right here. We can call that point C. You see that these 3 points are lined up and they create this straight line. We call that collinear in mathematics, and you can draw the line straight through. You can see that B is y intercept because that's where the line cuts through y-axis. And right here would be our x-intercept, which is which is 2, 0. So we have our x and y intercept. Now this stuff is really, really powerful in mathematics and gives us opportunity, right, to solve equations visually, come up with answers. Hopefully you are familiar with the fact that the car depreciates in value. And a lot of people would not buy a new car. They would only buy either used car or one that came back from lease because when you buy a brand new car, it loses a lot of value right away just by driving it off the lot. So if you buy, let's say, a $32,000 car and you want to sell it tomorrow, and it's just a day, right? You can't get 32,000 back for it. And that doesn't matter which car you bought. So they depreciate in value a lot, but also they depreciate in value as you put more miles on it, as you have dings and scratches on the body, right? And the headlights are getting fogged up, and all of that stuff starts decreasing the value of the car. And the graph for something like that would look like this. Now, on the y-axis, you would have your money, and on the x-axis, you would have time in years. Now, you have the intercepts. This is how they're used in what you would call a real world, because our math class is fake, obviously. So, if you take a look at the application for this, this would be the purchase price, and then whatever thousands, right? I don't know, 32K, whatever. And clearly right here is zero money. Years pass by, and you can actually approximate using this, right, that the car will be worthless some X years, right? Because you know how much you paid, then you can take a look next year, how much depreciated, the following year, how much depreciated. And if it's following this linear line, you can go far enough in the future and see when is that car going to be completely worthless, meaning having a zero value, right? And for most cars, right, it eventually happens. Now we have, you know, the range when the car is, you know, $2,000, $3,000, $4,000 worth, right, and then a little bit more and a little bit more and a little bit more. So these are all different parts of the different I want to say like price ranges. There we go, price ranges. So different price ranges, and we have we can use the graph and today's lecture to figure out where is going to be the x-intercept, because that x-intercept in this case will show the time, right, when the car is worth zero in terms of the value. Now, the same would happen with houses and everything else if they are not maintained, right? There is this big thing now going around that Italy is selling houses for €1. Now, if you go and research that, you will find that yes, Italian government is selling houses in Italy for €1. Now, you know, those houses technically are worthless right now. They were all worth some money when they were built, when people lived in them, when it was a livable space. And then after some earthquake that happened, people took the insurance money, and instead of staying in those little towns, they moved out with the insurance money. They moved out to bigger cities and, you know, search for a job, especially if they were younger, and so on. And then just abandoned those properties, which stayed abandoned for years and years and years, became all moldy and right. And many of them have cracked foundations from the earthquake, and walls, and, you know, broken in roofs and so on. So, you know, they are abandoned. So it's technically worthless. Now, when you are thinking about it, wow, it's actually a house, right? And it costs a lot of money. Yeah, that's that part where you have your y. Again, it's the same thing with the graph, right? You have that time when the house was made and was purchased, right? It was paid. That would be the y-intercept. And then, years later, right? Because it was abandoned and not fixed, and no one lives there. It's just a pile of rubble. It's worthless. So it's that symbolic €1, which is technically almost as the same as $1, right? But then you have to obviously go to Italy and work with right with people over there to restore it and renovate and so on. So might be more trouble than just building somewhere else. Cracked foundation is never fun. So that was another example of where you would, right, see that your y-intercept gives a value that is important to you, and then the x value gives, again, another data point. In both cases with the car and the house was, how long in the future, if you don't maintain it, either one of those two, how far in the future would both be completely worthless. So updating house is very important, right? Renovating and fixing and all of this kind of stuff. So if you are a homeowner, property owner of any kind, you know that it's a constant money drain to maintain. That's something that renters don't understand. They say, yeah, these people that own these houses just are sucking out money, but the fact is, they have to fix all of the problems that are constantly there, replace the roof and windows and all carpets and a whole bunch of stuff. It's just insanely expensive to do these things. So let's take a look now at the other concepts. So the first part of the lecture was all about x and y intercepts, which are the points on x and y axis through which the graph goes through and switches the quadrant technically. So that's the first part, very simple concept. And we can also compute them. Almost forgot. Let's put the big title for that. Compute x, y intercepts. This is insanely important. Let's make it important. You compute x and y intercepts with this setup. There we go. So these are zeros, and you know what to do. You plug x equals 0, you compute y, you write it in the chart, and then redo the problem, but this time you put y equals 0 and recompute the problem. So let's take a look at the example. Find x and y intercepts for, and let's say x minus 3y equals to 9, whatever. So you are given a formula and you study, right? And you remember the way to do it. So you go and you say, what I need to do is to populate this chart. So that's your setup. This is what you learned, memorized, whatever you want to call it. Now it makes sense because you know that the y-intercept has 0 for x and the x-intercept has 0 for y. So you can calculate now, from the first one, you can say that 0 minus 3y equals 9. So that's an equation from chapter 2. You are not learning new ways to solve equations or anything like that. You are only learning the concept that your y-intercept is calculated when you set x equal to 0. Now you see that in a chart because in a chart, right, once you remember the chart, which is this in red, stuff that you need to learn, the chart tells you plug 0 for x. And that's exactly what you did. Plug 0 for x. And now you have your negative 3y equals 9. Divide both sides by negative 3. And you have negative 3 for your first answer, because positive 9 divided by negative 3 is negative 3. So that gives us the y-intercept simply by plugging in 0 for x. Now to calculate the other, plug in y equals 0. And I will ask you to solve that problem. So plug in 0 for y and solve the problem. Let's see what you get.
I got 9.
Perfect.
I also got 9.
Excellent. So -3 times 0 is just going to be 0. So x equals 9. And the number that we fill in here is 9. So if we want to graph this, you would just put those two, numbers, y -3 and x equals to 9, and connect. Now graphing will be talked about later. So we can still 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the x-intercept, and then 1 to -3. And then you use the straight edge, or the cover of the book or whatever. But you can get these like for $1 in dollar store. And just draw the straight line through those. You have your x and a y. By the way, labeling these x and a y on a graph, that gives you a point. So make sure that you are doing that every time you have a graph. So it's very simple, as you can see, to obtain x and y intercepts through calculation. All you need to do is to plug 0 for x and then redo the problem, and 0 for y for x-intercept, and then go through the calculations to figure out. Okay. So this is what we have for x and y intercepts. We understand what they are, just the points on x and y axis where the line crosses the axis. We understand that we can compute them either through the chart, look on the graph, or compute them, what we say, algebraically, where you plug 0 for x to find y, and you find 0 for y to calculate x, and then you do what else? And then, obviously, I talked a little bit about application to make all of this actually useful, to talk about and understand how either stuff depreciates in value. But there are many other things that we use this in mathematics. It's not just this, idea with the straight line. Technically, any other shape that you have would have the x and the y intercept. So, for instance, the modeling, if you throw a stone, let's say your arm is at 5 feet, and you throw a stone, it's gonna create this and then hit the ground. You can see that there is the y-intercept at 0.5, and then let's say it goes 20 feet, the stone, so it hits the ground at 20.0. So again, it's not a straight line right now. When you throw any object, it always go in a parabolic motion, which is this kind of U shape. looking down, and you still have, even though it's not a straight line, you still have x and y intercepts. So these concepts of x and y intercepts will never leave mathematics. Every course will have this, and now in elementary algebra we are only dealing with this x and y intercept on the straight line. Those of you going to intermediate algebra and then following pre-calculus and so on later on, you will be looking for x and y intercepts of every possible curve that we can write the formula for. So that's obviously for later. Now the last part of today's lesson is another important concept of horizontal and vertical line. And when I say horizontal and vertical line, if you want to transfer that into your reality, you can think of, floor is horizontal, so it should be perfectly flat. If you put a marble on it, it should not roll unless the floor is crooked, which, in many cases it is. But if there is a hardwood floor in a room, or it's, concrete or whatever, putting the marble on top, it should not roll, because it would be a horizontal surface. So you should connect the word horizontal to horizon, right, where in the distance the ground reaches the sky. So there is that line is called the horizon, right? So horizontal line. So when we are talking about horizontal line, we are talking about the line. I'm going to draw that line using a different color now. So if you have your x and y coordinate system, so here is your x, here's your y, and now usually I use blue color for horizontal lines. This over here is the horizontal line. So it means it's flat. And if you are to put, I don't know, a coin over here or a marble or something, it should not roll on any of the sides. Now, horizontal line, obviously that's opposed to a slanted line, right? Which if you put something around here, it would roll down that line. So you know a lot about horizontal surfaces because you are alive and you are moving around this world. So you know that your road can be flat, or you can drive up or down the hill. So the flat one would be horizontal, right? And then surface of the desk, surface of the floor, surface of the ceiling, right? All of these should be horizontal, meaning flat. And later we'll define that through a number as well. We'll say it will have a zero slope, which also makes sense because flat surface, horizontal surface is not sloped because nothing will roll on it, right? Things only roll down the sloped surface. So your sloped surfaces, these are the two sloped surfaces, and these objects will roll down the sloped surface. But the flat surface is not sloped, therefore nothing rolls on it. And this entire line is defined by this point here. Let's call that point D. So equation, and this is something that you will be asked over and over and over again, homework exams and final exam as well. Horizontal line equation is y equals D. And that should be common sense immediately. Y equals D is the equation because this line is on the level whatever number D is. The way I drew it here, it's 2, but it could be on any other level. So if I make a new, let's make a new coordinate system and draw one or two of these, a couple, maybe we can draw more. So here is the coordinate system, and now I'm going to draw a couple of these horizontal lines. So I want to draw the same line as before. This would be the line y equals to 2, because it goes through y equals to 2 on a y-axis. And this line over here is what? Y equals, you tell me.
-3.
Perfect. And believe it or not, guys, that's it. You just look which number it goes through, and that's your equation. Okay, here's the annoying one. It's so hard to draw. There we go. So this is where the 0 is. How much is that one?
Four and a half.
Yep. You can write 4.5. You can also say 9/2. I don't care which one you put. Just read the number. That's literally all it is. All right. So read the number and write the equation down. So that's all it is. I'm just going to make this nice and straight because it's, there we go, better. And now the next part are vertical lines. And those would be like your walls, right? Vertical lines. So we're going to now take a look at lines that are, why is this red? Because I didn't change the color. So if I have now my X and the Y, vertical lines are going to go like this. This line over here goes through -3. This line over here is going through 2. This line over here is going through what? 3, 4, 5, 6. And they all have their equations. X equals -3, X equals 2, X equals 6, because you see that it goes through X equals that number. So equation is X equals some number. In this case, we can call that number C. So a number on x-axis, and that will be the value for the vertical line. Now, I would label this as easy, because the way I perceive this is just you look at the value and you say, oh, x is 3. Okay, the line goes through 3 on x, and you draw the vertical line. Or y is 7. Okay, that's a horizontal line through y equals 7. See, you cannot draw a horizontal line through x equals 2. That's x-axis, right? Through x equals 2, you can only draw a vertical line. So, I don't know, if you, I guess, sit down and think about it for 2 minutes, it should be common sense. Now, here is the problem that appeared at one point on the final exam, and very small number of students answered, not maybe 10%. And I was really puzzled because the problem was technically a freebie. It said, draw horizontal and vertical lines through, and then this point, I don't remember what it was. So let's say 3, -4. and write the equations. So the wording might have been different, but technically you have a point for the XY coordinate system. You are supposed to graph horizontal and vertical line going through that point and then give the equations for those two lines. So I'm going to give you about 18 seconds to do this, and then I will work out the problem. All right, let's take a look. So this is the entire solution, or everything you need to do for this problem. You go and you say, where is the point? 3, -4. 1, 2, 3. 1, 2, 3, -4. So this is your point, 3, -4. And literally all you need to do is to draw a vertical line. I usually like to draw those red. And draw a horizontal line. Write y equals -4, which you can see in the point. And write x equals to 3. Done. That's it. Now you can make this a little nicer by providing these divisions if you want to. But this is the entire problem, which, as I said, shows up frequently on homework, exam, and it was on the final exams as well that I've seen floating about. So you're supposed to draw or sketch or plot or whatever, or graph horizontal and vertical lines through the point that it's given to you. Now those numbers can be anything else. And then write the equations for those two lines, for the red and the blue. And we have everything there. So that's the story of vertical and horizontal lines, and the story of x and y intercepts. The homework will ask you to compute the intercepts and to draw the lines with intercepts, and then use that chart that I showed you. And then you have vertical and horizontal lines where you will have to graph those lines or read the equations right from the graphs that are given to you. And MyMATLAB will have all of that available. So, questions and concerns regarding this section? Anything? I guess that's no. In that case, that's it. I will see you all next time. Bye.